This is the review lesson A on page 17 for the PCAL Christian School Algebra 2 class. Hopefully working through these problems will help you a little bit before you move on to the next lesson. So if you will get your books out and look at page 17, we'll start with number 1, which is a review of the very first lesson that we did that gave some of you nightmares, I think. So let's work through a step at a time on that first problem. We have m squared n to the negative 5th power, and that's all in parentheses, and that's all to the negative 2nd power. Then we have m, and in parentheses we have n to the 0 power squared over, in parentheses we have m squared n to the negative 2 power, and all of that is raised to the negative 3rd power, and then we have m squared. And I'm probably going to run out of room really quickly here, but we'll see what we can do. Now remember, when you have one variable like this m up here, and it's being raised to 2 different exponents, when we have that situation, we multiply those exponents. So that becomes m to the negative 4 power, because 2 times negative 2 makes it negative 4. The n then is negative 5 times negative 2, which becomes n to the 10th power. Then we have this m. Now you know that anything to the 0 power equals 1. So this is just 1 squared, which is 1. So what we're saying up here is all of this in the numerator is being multiplied by 1. So we can just drop that 1. All right, so on the bottom here, we have the same situation. We have 1m here, but it's being raised to 2 different exponents. So we have m to the 2 times negative 3, which becomes m to the negative 6th power. And our n is to the negative 2 times the negative 3, so that becomes n positive 6, and then we'll just bring down our m squared. Now you notice we've simplified quite a bit, but if you look up here in the numerator, we can still simplify some things up there, and we can still simplify some things in this denominator. So back up to the top. Now we have 2 m's raised to exponents. Remember, there's an understood 1 with that m. So this becomes m. In this case, we add the exponents because we've got 2 bases raised to exponents. So we're going to add negative 4 plus 1, which gives us negative 3. And we're going to bring over our, oops, that should be n. That should be n to the 10th power. Over, we can simplify the m's here because we've got 2 m's. So we're going to add those. M to the negative 6 plus 2 becomes m to the negative 4, and we'll bring over the n. All right, so there, if you'll look, there's nothing left to simplify on the top or the bottom. So now we're going to do what we call flattening the problem. We're going to bring everything in the bottom up to the top and pair them up. So here we've got an m to the negative 3 already here. We're going to bring this other m up, and that negative 4 will change to a positive when we bring it across the fraction sign. We have an n to the 10th. We're going to bring this bottom n up, and the exponent changes to a negative. Now we're going to combine those by addition. Negative 3 plus 4 is m1, n 10 minus 6 is n4, and then you don't even need that 1, and this is the answer to our problem. Now when you look at that original problem, it looks really overwhelming. If you'll just take it a step at a time, you should be fine. Now number 2 is a little bit different because we're adding some things together. So let me clear my screen here and we'll work on number 2. You notice how low tech I am. I know there's got to be a way to do this a little more professionally, but I haven't figured out how to do that yet. I can change color though. Let's find a prettier color here. Okay, so the second problem is negative 2x to the 5th y to the 4th plus 3xy to the 3rd power over x to the negative 4 y negative 1 plus 4x cubed y squared over x squared y. Okay, the difference here is we've got 3 different terms being added together, but we're still going to do the same principle. Now if you'll look at this first term, there's nothing we can really do with that, so I'm just going to bring that down and leave it as is, negative 2x 5y4. But if I look at this second term, I've got a 3 up here. I've got an x here with an understood 1 and an x to the negative 4 on the bottom. I need to combine those x's. So I need to bring the bottom x up, and when I do, it's going to change to a positive 4. So that's going to be the 1 that's already there plus the 4, and that becomes x to the 5th power. We're going to do the same thing with the y's. We need to combine them. So I've got 3 y's on the top. I'm going to bring this y up, and that negative 1 becomes a positive. So we have 3 plus 1, so that becomes y to the 4th power. We're going to do the same thing on this last term. We've got the 4 we're going to leave alone. I've got x cubed on the top. I'm going to bring the other x up, and it becomes a negative, and that just becomes x to the 1 power, or just x. And the y, we have 2 on the top. We're going to bring 1 up because there's an understood 1 and subtract it, and that becomes y to the 1. Okay, there's nothing left in any of these terms that we can simplify. Nothing we can do in this first term, nothing we can do in the second term or the third term. The only thing we can do in that third term is take out these 1s because we don't need them. So now let's look and see if we have any like terms. Our variable here is x5, y4. Here's another x5, y4. Those match. Those are like terms. This 4xy is not a like term. You see, it's totally different than the x5, y4, so we can't add it. So we're just going to leave it alone. And that will be part of our final answer. But let's look at these 2 that we can add. We have 3 x5, y4s. We're taking away 2 of those x5, y4s, which leaves us with 1 left. So we have 1 x5, y4, and that's the answer to our problem because those are not like terms and we can't combine them. Now, you don't need the 1, so that would be the same answer if you wanted to leave it like that. All right, let's move on to number 3. Let me clear my screen here. Let's see if I can do it like this, a little easier. Nah, that didn't work very well, did it? Okay, let's just do it like this. I need to play around with this a little more and get a little better at it. But hopefully this will help you to be able to look back at things. All right, what color do we want to go with for this one? We'll go some blue here. Okay, number 3. This is one of those simple substitution problems. xy minus xy plus y. Now there's nothing we can do there. We could move some things around, but we can't really come up with an answer until we know that x equals 2 and y equals negative 3. Now we know some things that we can plug into this expression. we're looking for xy, x times y. Here's x and here's y. If I multiply those together, I get a -6. Minus, now we have to do what's in the parentheses according to our order of operations. So xy again is still -6 plus y. Y is -3. Okay, hopefully you're following along with me. So let's look in this parentheses. Let's go ahead and bring down our -6 minus. -6 plus -3 becomes a -9. Now, everything is, all the multiplication is gone. We have no division. Once we're left with just addition and subtraction, I don't need parentheses anymore. So let's make it a little easier to see what we need to do. What happens when we have a negative? That becomes -6 plus 9, which equals 3. And that's the answer to that problem. Okay, let's do number 4, then we're going to take a break. And if you need to, keep watching this until you get it. That's the purpose for me doing this, is so you'll have something to look at to help you. Okay, number 4. This is one of those long ones. We've got -3 to the 0 power, -2 to the 0 power, -2 to the 0 power, parentheses, -2 minus 3 squared, close parentheses, minus parentheses -2 plus 7, minus absolute value of -2 minus 3. All right, here's where your order of operations is crucial. So we're going to do parentheses first. So I'm going to bring these down. -2 minus 3 squared is 9 equals, oh, sorry, that's not an equal sign, that's a negative. Minus -2 plus 7, that's 5, minus the absolute value of -5. All right. Next step, bring down, bring down, bring down. This becomes -11, minus 5, minus. What's the absolute value of -5? If you remember, absolute value is always positive because it just means how far is -5 from 0. And it's 5 spaces. So that just becomes a -5. Okay, so now we've got all of our parentheses done. Now we're going to do some multiplication here. So we've got -3, 0, -2, 0, -2, 0. Up. That should be, let me erase that. That should be -2 to the 0 power times -11, which is positive. You know what? We didn't do exponents. Let's back up. I was multiplying out of order. We've got to do our exponents first. Parentheses, then exponents. Remember, anything to the 0 is a 1, but this negative is not in parentheses, so we don't include that. The only thing this 0 power goes to is that 3. So that becomes a -1. There's another 0, -1, -1 times -11, -5, -5. Okay, hopefully I didn't confuse you there. Let me rewrite this. I got my numbers out of order. Okay, now we've got a multiplication here we need to deal with. So we've got -1, -1. -1 times -11 becomes +11, -5, -5. Now you notice all our parentheses are gone, all of our exponents are gone, all of our multiplication is gone, and all of our division is gone, and we're only left with addition and subtraction. And now we can finish our problem. So we've got -1 plus -1 plus 11 minus 5 minus 5. If you will add all that up together, you're going to end up with a -1 as your answer. Okay, we're going to take a break for a few minutes, then I will come back and do another video to finish this review. Go back and watch it again as many times as you need to until you get it, okay? See you in the next one.